All right, welcome back. Part 2 of rational functions and models. We're going to look here at how to graph a rational function. So we're going to let p of x over q of x define a rational function in lowest terms. In order to sketch its graph by hand, we're going to follow these steps. First step, find all vertical asymptotes. Second step, find, not final, find all horizontal or slant asymptotes. Oblique is another word for the asymptotes. We're going to find the y-intercept, if possible, by evaluating, boy, somebody did not proofread their notes here, by evaluating f of 0. Find the x-intercepts, if any, by solving f of x equals 0. This will correspond to the zeros of the numerator p of x, and I just uploaded part 1. Forgot that was going to pop up. Step 5, determine whether the graph will intersect its non-vertical asymptote by solving, or solving to see if it's going to cross its slant asymptote. So we can cross the non-vertical asymptotes, right? The horizontal and the slant asymptotes, we might cross those. And those are interesting points that we need to keep in mind, but we will not cross vertical asymptotes. And then we'll plot as many points as necessary. So let's see if we could follow these steps. First step is we're going to find all vertical asymptotes. So we'll set the denominator equal to 0 and solve. So we'll have a vertical asymptote at x equals 1. Step 2. Find all horizontal or slant asymptotes. So when I compare the degree of the numerator to the degree of the denominator, I find they're both linear. So I know that y equals 3 over 1, or y equals 3, is a horizontal asymptote. Step 3, let's find the y-intercept. F of 0 is 2 over negative 1. Notice everything with an x will become 0, and I'm just left with constant terms. So this is negative 2. We have a point 0, negative 2. Number 4, find any x-intercepts, if any, by solving f of x equals 0. Excuse me. This will correspond to the zeros of the numerator. Here's why. A little note up here. If I have 0 equals p of x over q of x, my first step is going to be multiplying both sides by q of x, and this nice bright yellow, so that it cancels. What is q of x times 0? That's 0. And so that's why solving f of x equals 0 for a rational function corresponds to finding zeros of the numerator. So for step 4, 3x plus 2 is equal to 0 when x is equal to subtract 2 divided by 3. So we'll have an x-intercept. And then let's come back to this. Let's put our framework down, see what we have so far. We have x values. Let me see. It looks like 3 is the highest we go anywhere. Make sure those are negative. Okay, so x equals 1 is a vertical asymptote, generally indicated by a dotted line. Y equals 3. Horizontal asymptote. Did I just call that last one horizontal? I meant vertical. We have a point at 0, negative 2. And we have a point at negative 2/3, comma 0. Alright, so this is not a point. This is a poorly conceived line. There we go. There we go, at negative 3. So it looks like we have part of a graph over here. We have 4 sections that we have to kind of take a look at. And over here, we can kind of fill out what's going to happen. Just because we have an idea of what rational functions do with horizontal asymptotes and with vertical asymptotes based on placement. But we don't have any information about up here or over here. So step 5, we could see if we're going to cross the horizontal asymptote, but I'm telling you in this one we're not going to, and for sake of time, I'm going to just skip that step. We're going to plot selected points as needed. I have no idea what's going on over here. So I'm going to choose an x value. This is step 6. I'm going to choose an x value of 1.5. I'm going to choose an x value of 2, and I'm going to choose an x value of 3. And when I evaluate this, what I'm going to do is I'm going to store 1.5 for x, store for x, and then I could type in 3x plus 2 divided by x minus 1, and find that that value is 13. So I have a point 1.5 comma 13. That's way up here, not to scale at all. Now I could put in 2. So I'll do 2, store for x, enter. But I don't want to have to type all that again, so I could do second entry, bring it up, and I'll get 8. So I'll have a point 2 comma 8. 2 comma 8. Now I'll put in 3. So we'll do 3, store for x, bring back that expression, and I'll have 5.5. That's 3, maybe 5.5 is over here. And so we can kind of see that I really placed this graph in a bad location. It's eventually going to get close to our vertical asymptote. This is a very ugly version of this graph. Check it out. If you want to see a prettier version, it is a 3x plus 2 divided by x minus 1. When we take a look at the graph, I'm going to zoom it back out. Let's go with a standard window. And we can see more or less the structure of the graph that we have just kind of skewed. I didn't leave us enough room. And then we completed the sketch, as you see. All right. Let's look at problem number 2 of this type. Okay, so step 1. I am going to find my vertical asymptote. 2x plus 4 equals 0. Let's subtract 4. Let's divide by 2. I have a vertical asymptote of x equals negative 2. Second step, horizontal asymptotes. When I compare the degree of the numerator to the degree of the denominator, I see the numerator is higher. So this is no horizontal asymptote. That's right, we're going to graph a slant asymptote. No horizontal asymptote. So while I'm here, I'm going to divide 2x plus 4 divided into x squared plus 0x plus 1. All right. So what do I multiply 2x by to get x squared? That'll be a 1/2 x. So half of x times 2x is x squared. Half of x times 4 is 2x. Draw the line minus sign here. Subtract. X squareds cancel out. I'll have a negative 2x plus 1. What do I multiply 2x by to get a negative 2x? That's going to be a minus 1. It's a negative 2x minus 4. Draw the line minus sign. Cancel out. 1 minus a negative 4 will be 5. So this is our remainder, and this is the equation of our slant asymptote. Right, the quotient. So we're going to keep that in mind as we graph this. Step 3, we find the y-intercept. Remember, substituting 0 for x will cancel out every possible x term. So I'll have the point 0, 1/4. The x-intercepts are the same as setting the numerator equal to 0 and solving. Notice there are no solutions. That's an O. No solutions because when I square a number, a real number, it's either 0 or higher. When I add 1 to that result, it'll be 1 or higher, so it'll never be 0. So no solutions, no x-intercepts. I could find out if I ever cross my slant asymptote, but this one will not. Let's see what we have right now. Let's see what we have going on. I'm not going to make the same mistake. I'm going to leave plenty of room here. Let's go 1, 2, 3, 4, 5 in each direction. And let's see what we have. We have x equals -2. All right, there's x equals -2. We have y equals 1/2 x minus 1. So here's minus 1. Go up 1 over 2. And we're going to put this as a slanty line. All right, our slant asymptote. We have 0, 1/4. 0, 1/4 is a point on the graph. And there are no x-intercepts. Interesting. So I have no idea what's going on to the left of -2. And so in order to find those values, we'll evaluate. A quick reminder that our f of x is x squared plus 1, now that it's off the screen. We're going to evaluate when x is, say, -5. We'll evaluate when x is -4. Let's go at -3. I'd kind of like to see what's going on here at -1. We know it's 0. How about at +1 as well? And if we're going to evaluate at all these different values, it'll probably be best to go here to our graph. Turn the calculator on. This is not the graph we're looking at. We're looking at the graph of x squared plus 1 divided by 2x plus 4. This will give us an idea, but more importantly, really what I want to see is the table. I want to evaluate when x is -5, I'll have a -4.3. And since we're graphing this by hand, close enough is good enough. -5, -4.3. All right. -4 gives us -4 1/4. -4 1/4, about right there. At -3, we're at -5. And we can fill out this portion of our graph. If you ever miss a point, just make it bigger. It's all good. Now what's going on over here? Now we'll evaluate at, -3 has -5. I'm going to look at -1 and 1 at the same time. -1 has an output of 1. +1 has an output of 1/3. So -1, 1. +1 is 1/3. 1/3 slightly higher than 1/4. And so we can model what we see in the calculator to sketch the graph. Sketching the graph of a rational function by hand. Take it a step at a time, fill in the values that you know, and then you know which values you need to evaluate. If you just start randomly picking numbers to try to figure out what this graph looks like, it's not going to go well for you. So definitely figure out the asymptotes first, get kind of a framework or a structure for it. That's it for rational functions graphing by hand. Thanks for listening.